guys, we are going to be doing the last section of the chapter, but it's technically not in the chapter. As you see listed up there, it says BA1. So I think in the textbook it's after chapter...
It's between chapter 10 and 11. If you close your books, it's the purple pages in the middle.
Right. So, but we put it in chapter 2 because it's just logic and thinking how we represent different sentences with Venn diagrams. And I know you've seen these before, maybe in English class. What I would like you guys to do is draw out these three different representations of how sentences can be. So when you see the word always, it's going to be this diagram. And if you think about it, if I just say, if I put label A and B as our bubbles there, A is always going to be B. Okay, so anytime you see something with always, the A has to be inside. If something always is the other. Sometimes, just you guys remember, it's that shared common sense. Sometimes A might be B because it's connected there. And lastly, when they're not touching, that's a none because they have nothing in common. So we'll go ahead and give you 3 example sentences, and I want you guys to pause and see if you can draw out the 3 Venn diagrams that would represent these bubbles.
Okay.
And
so hopefully you guys came up with the same thing we came up with.
Okay.
It's coming.
there we go.
Okay, so for all, remember we said all students in SCA are taking AP Government. So SCA is the smaller group here, and they're all going to be within AP Government. Some, so we're going to have an intersection, and none, so they're not going to touch at all.
All right, so let's look at another way we represent the Venn diagrams, and we put this box around it. See if you can properly label where maybe both, only, and none might be.
Okay, so after you've had a chance, I would put both not there. Nope, and yes. So both, remember we said, is the sometimes, so that's where both things occur the same way. Only would be here, but it could also be here. So it's only the part of the circle that's not overlapping. And there would be no one in either of those sets, either anywhere on the outside. I could put it there, I could put it down here, I could put it down here. But out here, we're not talking about the set of data anymore. So we want to make sure it's in the box.
All right, so let's go ahead and put some numbers into a diagram. Oh, I'm sorry, I jumped ahead. We are going to practice labeling. Go ahead and pause and read through 1 through 5. And place the different things within this Venn diagram, and then we'll go ahead and check that you guys did it correctly.
All right, so this just practices if you understand the words only, both, sometimes, always, or not at all. So hopefully you guys came up with this. Okay, so double check your answers, and then let's go ahead and actually do some practice this time. All right, so there were 205 seniors, and of those 205 seniors, 135 applied to colleges out of state, 120 applied to colleges in state, and 75 applied both to colleges out of state and in state. So both, okay? So where does that 75 go? We said both was the intersection, so I can go ahead and put that 75 down immediately. The only other number I'm comfortable putting down right now is the fact that we had 205 seniors. So I'm going to put that on the outside, saying that this box contains 205 surveyed seniors. Now, how do we deal with the 135 and the 120? Well, one of these circles needs to be out of state, and the other one needs to be in state. So we'll go ahead and label that out and edit. All right. This might, should we answer the questions first or finish filling in the diagram?
Let's go ahead and fill in the diagram so it makes the questions a lot easier if everything's filled in.
All right, so they said 135 of these seniors apply to colleges out of state. Well, keep in mind 75 of those 135 have already been placed in this Venn diagram. So what we're going to do here is 135 minus 75. Okay, so that's going to give us 60 seniors that only applied out of state. In state, they said 120 applied, but again, that's 75 still represented already. So we're going to do 120 minus 75, and that's going to give us 45 seniors that applied only to in-state colleges. Now, does this represent 205? Add those up real quick. 60 plus 75 plus 45. We should come up with 180. Okay, so that's not everybody that was surveyed. So what do we do with the leftovers? Well, the leftovers is going to be our none. So I'm going to do 205 to fill in our none minus 180. Okay, and that gives me 25 seniors that didn't apply to college at all.
So really, if you want to check to make sure you did all your math right, these four numbers, the 25, the 60, the 75, and the 45, those four should always add up to equal the total that you put up here. So if you add them up and they're not the 205 or whatever your total is, then you've done your math somewhere wrong. And typically, it's because you forgot to do the subtraction part. Subtract out that both. So now that we have everything filled in, let's go ahead and answer the questions. How many applied to only colleges out of state?
Okay, so where's that only part? Here's the only part, so 60.
How many applied to only colleges in state?
Okay, hopefully your answer is 45.
How many did not apply to college at all?
So that's the part where we aren't in one of the circles, so we're going to say that was the 25 students.
And lastly, how many applied to in-state or out-of-state or both?
Okay, the ors mean I'm going to include everybody in each category. So we had in-state, which was 45. We had out-of-state, which was 60. And we had both, which is its own category of 75. And we've already done that math over here. So I've got my answer of 180 students.
Great. All right, so right now let's pause it and see if you can fill in this. And remember, you need to keep reading those keywords, the only, the both, or whatever they're giving you. Okay, so let's go ahead and check to see if you've gotten these all filled in and answers correct.
How'd you do? Give yourself a pat on the back if you got everything right. You can have your circles backwards from ours, not a problem.
All right. So last Venn diagram, we're going to get all crazy and complicated and throw in a third bubble there. But it's kind of the same process. When you have three bubbles, they like to label them always the same way in the same order, where the all three is actually in the bottom. So that's where I'm going to start, is at the bottom, and then we're going to work our way up to the top to fill in the bubbles first before we get into the questions. So 20 students like all three, so this is where we're looking where all three intersect, and that's always in the middle. So I have 20 that will go in the middle. So we're done with that. Check, done with the first one. Now, it says 35 students like both pizza and macaroni and cheese. So when I look at the pizza and the macaroni and cheese intersection, that's actually this part here that I'm highlighting. Well, as you can see, I already have 20 in there. So I'm not going to put 35 here. That is incorrect. We already have 20 there, so we're going to do 35 minus the 20 to get that intersection, and that intersection then will be, hopefully you can do that math part, that intersection will be 15. So now 20 plus 15 gives you that 35. So we're done with that one. Let's continue to work our way up. 38 students like both ice cream and macaroni and cheese. So let's look at the intersection of ice cream and macaroni and cheese. That's what I'm highlighting here. Well, once again, there's already 20 there. So when we are going to figure this one out, we do 38 minus the 20. So that intersection there, or that part of the bubble, will be 18. And lastly, I'm going to use the green here. Let's check off that we've done this one. Okay, moving up to the top, 30 students like both ice cream and pizza. So in the green, that's this part here. Well, there's that 20 still lingering in there, so we're going to do 30 minus 20 to give us 10 for this part. So just like with two bubbles, you've got to subtract out that share that both in common there. Now, we're still not done with this. We need to figure out these three numbers here. And we're going to use the three left over at the top, starting at 64 students like macaroni and cheese. Okay, so let's look at that macaroni and cheese bubble. Well, if you take a look right here in blue that I'm highlighting all the way around, we already have 18, 20, and 15 included there. Okay, so if we add that up and subtract out with the macaroni and cheese, the 18 plus 20 plus 15 gives you 53, so we're going to do 64 minus 53 to get that only part, which is 11. Okay, moving on up, 57 students like pizza, so let's look at the pizza bubble. I'm going to do that in red. I know I'm getting you probably a little bit confused with all the colors, but this bubble here, representing pizza, we have 10, 20, and 15 already inside there. So we're going to add those up, which gives you 45. We're going to take that and subtract it from 57. So 57 minus 45 will leave us with the 12 that goes here in the pizza bubble. And lastly, the ice cream. Okay, 62 students like ice cream. Well, once again, when we highlight just this bubble here in green, we already have 18 plus 20 plus 10 in that section. So when you add that up, you will have 48 already inside the bubble. So 62 minus 48 will leave us with the 14 that will go and represent that part, the only ice cream part. So now, whew, we had everything filled in. So remember, start from the bottom up, and we just continue to add and subtract, add and subtract. And now we can read, how many students only like pizza? So remember, that only part means that we're just looking at this number here because it's not touching any of the other bubbles or intersections. So 12 will be how many students only like pizza. How many students only like ice cream? That's the 14 that we found out last. And finally, last question, how many students only like macaroni and cheese? That's that 11th part there. Okay, and the setup's normally the same for all of these, like I said, where you start from the bottom and work your way up.
All right, so this is the end of chapter 2. We are done. So big sigh of relief. Put your pens down. Woo!
Chapter 2 is done.
Okay, we'll see you in class tomorrow. Get ready for your test. Rewatch any videos you feel like you need to retouch on.